Welcome to the Who, What, Why podcast. I'm your host, Jeff Schechtman. Most of us are well aware of the physical threats posed by climate change. Rising sea levels, extreme weather, oppressive heat. But what about the invisible ways that a changing environment impacts us? What about the toll on our brains? Yes, our brains. My guest today, Clayton Page Aldern, argues that the mental health dimensions of global warming constitute a public health crisis that has gone largely unreported. Aldern is a neuroscientist turned environmental journalist whose work has appeared in The Atlantic, The Guardian, The Economist, and many other publications. His climate data visualizations have been featured in the U.S. Senate and put forth by Senator Sheldon Whitehouse. In his new book, The Weight of Nature, How a Changing Climate Changes Our Brains, Aldern brings together cutting-edge research and powerful stories to illustrate the many ways that climate change is affecting our brains and our behavior. Hotter temperatures hindering cognitive performance, air pollution wearing on our memory, wildfires seeding PTSD. Aldern takes us from farms in California to Arctic Norway to the Micronesian islands. In so doing, painting an unprecedented portrait of an overlooked crisis. But this isn't just about climate anxiety. It's a clarion call to integrate the profound neurological impacts of climate change into our discussions before it's too late. It's also a celebration of human resilience and our capacity to come together in the face of existential threats. Clayton Aldern is a neuroscientist turned environmental journalist. He's a Rhodes Scholar and a Reynolds Journalism Institute Fellow. He holds a master's in neuroscience and a master's in public policy from the University of Oxford, and he's a research affiliate at the Center for Studies in Demography and Ecology at the University of Washington. It is my pleasure to welcome Clayton Page Aldern here to talk about his newest work, The Weight of Nature, How a Changing Climate Changes Our Brains. Clayton, thanks so much for joining us here on the Who, What, Why podcast.
Hey, Jeff. Thanks for having me.
Well, it is a delight to have you here. One of the things that is clear is that this subject has certainly been underreported. Talk a little bit about how the research on this, the research into the mental health consequences of climate change, really began to emerge and take root.
Yeah, well, mental health and, as I'm sure we'll discuss, neurological health, right? This is also about the physical effects of a changing environment on our brain tissue. And, you know, where did any of this come from? It came from a variety of disparate fields, right? I think a lot of my work here has been an effort to unite a series of threads that I began to pull at in behavioral economics, in cognitive neuroscience, in psychology, in epidemiology, right? With all of this research pointing toward effectively one truth, which is that our brains are enmeshed in the environment, right? They're always reaching out. That's what brains do. They seek to model the world around us, and they take in information about this world. And in doing so, they by definition reflect that world. They reflect the world around us. And so as that world changes, we should expect to change in kind.
And is this change strictly as a result of the fact that what our brains are adapting to is, because of climate change, fundamentally different? Do those, for example, that live in equatorial environments, that are used to the kind of heat that we might envision in other parts of the world as a result of climate change, that have already adapted? Talk about that difference.
Yeah, happy to. Right. No, I mean, this is a universal shared experience, right? Everybody with a brain, which is to say everybody, lives relative to their own environmental context, and it is fluctuations in that environmental context that result in the fluctuations in brain health that I write about in this book. That's not to say that some of these effects aren't going to be felt more by those living in vulnerable communities, for example, that are exposed to something like extreme heat deviations, right? Heat waves, for example, on a more frequent basis as a function of climate change. But the core truth here is that we're talking about the relationship between environmental change and brain health, and everybody is embedded in an environment. So to the extent that the reference frame of climate change is useful, it's really it to me is a process by which we can notice the changes in question, right? Pay attention to these relationships. But there's nothing special about climate change per se, right? Uh, the fact that the climate is changing is that which allows us to pay closer attention to some of these effects. But really, we're describing basic, and by basic I mean fundamental biophysical relationships between environmental change writ large and neural processes.
Talk about the way that our brains adapt. There is a certain degree of neuroplasticity that we certainly have. Talk about why this is different, why the adaptation may not be as rapid.
Yeah, I mean, that is what brains do, right? Brains adapt. The point of the brain is to model the world around it. And what I mean by that is you have this organ that is taking in all of this sensory information about the world and modeling the statistical regularities of that information, such that you, as someone who experiences this model, someone whose self is exposed to the expectations implied by this model, you can navigate the world accordingly, right? If you were constantly surprised by the fact that you had two hands or that the sky was blue, you wouldn't be able to get anything done. You'd live in a constant state of shock and awe. But instead, what your brain does is it models the expected relationships that you are likely to have with the world and likely to have with yourself. And it is only the manners in which those expectations are upset that we see changes made to the model. So it is abnormal for the sky to be orange when a wildfire comes to town. And so we pay attention to it, right? Our expectation is that the sky is blue, but these moments in which there's a drastic environmental change, they surprise us. They upset our expectations. They cause us to pay attention. That's kind of a metaphorical, but no less real description of what's happening when we as organisms encounter environmental change at all. We are made to adapt to changing environments. We have very flexible brains, but they are not infinitely adaptable, right? I think some of the estimates that epidemiologists have put out in terms of our brains and bodies' ability to adapt to coming climate changes with respect to maintaining our health, these estimates suggest that we can maybe adapt away something on the order of 50% of the expected health costs of climate change. But the rest of it, we're kind of hung out to dry, unfortunately, and we're going to need to think about more than evolutionary adaptation, right? More than what is it that our bodies can do to protect us.
Is there at all in this an inherent positive ability for us to adapt, that by putting us on alert, essentially, as you were talking about, that it makes us, in paying attention more, it does something to us neurologically that has inherently in it something that helps our ability to adapt?
Yeah, I think that's a very nice insight, and actually it aligns with some research that has recently been conducted on folks who do experience something like climate anxiety, right? So you've probably heard this phrase before. Much of my book is not about climate anxiety. It's about the direct impacts of environmental change on the brain and on decision making and neurological health. But the climate anxiety example is useful here with respect to your question, because what some researchers in Michigan found, I think this paper was just published this month, was that if you compare the brain of somebody who expresses a high degree of climate anxiety to someone who expresses a low degree of climate anxiety, and controlling for kind of base levels of trait anxiety, right? The presence and degree of generalized anxiety disorder, isolate that kind of cognitive emotional effect of climate anxiety per se. What do you find? You find in these folks a smaller region of the brain known as the mid-cingulate cortex. And while this region, which is responsible for effectively responding to threats about uncertain futures, uh, despite a smaller mid-cingulate cortex, you see increased connectivity between that chunk of the brain and those that are involved in other forms of rational decision making in the face of uncertainty. So, what does that imply in terms of the experience, the lived experience of people with climate anxiety? It would seem to suggest, I think, in the spirit of your question, that the adaptations, right, the evolutionary adaptations that have resulted in this smaller mid-cingulate and boosted functional connectivity between that region and other decision-making centers, it would seem that adaptation, it effectively attunes people to the threats of climate change in a manner that others without those morphological changes might not be privy to. And so there is something perhaps to be said. And again, this is very early work. It's hard to say the extent to which these findings will be replicated and further improved in terms of our understanding. But it seems fair to say at this point that there's something to be said for the adaptations that the brain has been able to undergo over the long workshop of evolutionary history, and our ability as holders of those brains to respond to both detect and respond to uncertain environmental threat. That one adaptation is actually the ability to recognize the threats in the first place.
Is there a percentage temperature change or a specific temperature that really creates fundamental differences here?
Well, it kind of depends who you ask. I mean, people live in a narrow thermal band of comfort insofar as we're very good at living our lives when it's 68 degrees Fahrenheit, for example. We're really good at performing all kinds of cognitive tests, and we're really good at being nice to one another, right? Productivity skyrockets. Plenty of behavioral economic research, for example, does appear to identify this biophysical set point that caters to a kind of experience of the world that we would identify psychologically with, human flourishing or whatever. And at the same time, it does appear to be the case that irrespective of where one is on that temperature scale at any given point in time, every extra degree matters. So it's not necessarily about being in the precise zone of thermal comfort. It's not necessarily about reaching some kind of threshold after which you magically become more prone to violence and a more impulsive thinker, for example. But rather, as temperatures rise incrementally over the course of a day, over the long sweep of climate change, right? At all time scales, it appears to be the case that there are detectable effects of temperature deviations on cognition and behavior.
There's also other things that happen as a result of climate change and the impact that they have beyond just heat, but also storms and fires, as you mentioned before, and the consequences of all of those in terms of brain health.
Yes. And I'm glad you're bringing it up, because this is not just a story of heat. Climate change isn't a story just of heat. It's a story of extreme weather and acidifying oceans and rising carbon dioxide concentrations. And if you take into account the causal pipeline, it's also a function of fossil fuel emissions, right? And what do we know about fossil fuel emissions? They're also stuffed with things like particulate matter, right? Air pollution is also really bad for our brains. And so I think the story here is one of people being exposed, unlike in a lab, right, where we study the brains of rats, for example, and can selectively expose one animal to one environmental toxin at a specific point in time and watch what happens as a function of that exposure. Unlike in the lab, people are being exposed to a chronic soup of environmental exposures over the course of their lives. And so we are living in this experiment today. And what do we know about this experiment? We know that in addition to the behavioral effects we've already discussed, we know that air pollution, for example, is one of the most compelling explanations for the incidence of something like neurodegeneration, right? Dementias like Parkinson's and Alzheimer's. We know, for example, that climate change is increasing the habitable range of brain disease vectors like ticks and mosquitoes, right? The kinds of things that cause cerebral malaria and yellow fever in people. We know that people are exposed to a greater number of neurotoxins as a function of climate change because, by way of illustration, cyanobacteria, right? Blue-green algae are blooming at greater frequencies and in greater quantities in warming waters. And what do cyanobacteria colonies do? Unfortunately, they appear to release a neurotoxin that appears to be airborne and is one of the primary causal explanations behind the risk of something like ALS, right? Lou Gehrig's disease. So there are some real kind of intimate biophysical impacts that we're talking about here, and that's to say nothing of the mental health burden that no doubt listeners might be familiar with, right? We touched briefly on climate anxiety, but we also know, for example, that landscape loss and the patterns of change to which people are exposed as a function of a changing climate and environmental degradation, those patterns of change are related to major depressive symptomology, right? If you grow up at the base of a mountain and as a function of mountaintop removal mining, that landscape changes drastically. Your likelihood of experiencing major depressive symptomology relative to someone else who lives in a mining town, but a town that does not practice mountaintop removal mining, much less compared to somebody living in a town that is not a mining community, your risk of expressing major depressive symptomology skyrockets. You are perhaps familiar with the notion that extreme weather and natural disasters, wildfires, hurricanes among them, can be some of the most common triggers for something like PTSD, as opposed to something like combat, right? You don't need to go to war to experience post-traumatic stress. This is an unfortunate, relatively common mental health outcome for people who experience extreme weather and natural disasters. And so it's really a suite of exposures, and these exposures are manifesting at the level of the cell, the level of the individual, and the level of the relationship between individuals, how we treat one another.
From a practical perspective and from a public health perspective, is it more complicated as we think about this as something related to climate change or something related to environmental issues specifically? Because even though the two are deeply intertwined, as you're talking about, in terms of the way policy deals with these issues, it's fundamentally different.
I think that's right. When I think about the implications of the fact that we're talking about climate change per se here, my view on the policy angle is that, I mean, listen, for better or for worse, climate policies specifically is a function of cost benefit analysis. Right? This is true in many policymaking worlds, but it's true at an almost visceral level in climate policy. Right? Investments in climate action aren't going to occur unless they're justified. And what does it mean to justify them? The benefits of those investments need to outweigh the substantial costs, right? There's still a narrative that suggests, and indeed in many times is accurate, though not all instances, that solving climate change, as it were, is a very expensive thing to do, right? The technology is expensive. And so because of that, right, and because the societal changes that are needed to institute these solutions are also effectively expensive, it's really important that we're cataloging all of the costs that climate change is already affecting on people in the present. Because if we're not accurately accounting for those costs, we have no chance of justifying investments in solutions. So what we're not doing today, I would argue, is cataloging the neurological costs of climate change to the extent that I believe we should. What does it mean that we are facing the climate problem versus, some facet of environmentalism or conservation politics or whatever it may be writ large? I think, unfortunately, the reality here is that, at least in the United States, where I live, climate policy is by definition more hyperpolarized as a discipline. It's a more hyperpartisan act, and so I think the politics can get in the way, but the fundamental truth of climate policy running on cost benefit analysis still stands, and it's important, I think, to focus on the costs that we are not yet realizing in terms of our modeling efforts, in terms of these cost benefit analyses, as we move toward some semblance of action.
In that respect, do we do better if we put it under the rubric of public health?
Well, that strikes me as an empirical question. I would love to know if, for example, one framed these investments as public health investments as opposed to climate solutions investments, if they would be more readily implemented in a society like ours. My knee-jerk reflex says, well, maybe that sounds awfully good, and at the same time, we know from evidence that was unearthed during the coronavirus pandemic, for example, that public health policy isn't necessarily less readily hyperpartisan or polarized than climate policy per se. So I part of me wants to say, yes, of course, everybody can get behind the fact that we all have bodies and brains, and investments in climate solutions, for example, are public health investments. And at the same time, I worry that the hyperpolarized nature of U.S. politics would suggest that even public health arguments fall on partisan ears.
Talk about what you're seeing in the way awareness of this, coverage of it, etc., is beginning to expand, and where do you see that going?
Well, even 5 or 6 years ago, when I first began writing this book, climate anxiety as an idea was a relatively new idea. And now that's not true. That's a ubiquitous phrase. And I think most folks know what you're talking about when you deploy it, which is also one reason why this book is not about climate anxiety. I think it's a well-covered and reasonably well understood subject. I think we're at a moment now with respect to the neurological costs of climate change, the biophysical effects in the brain as a matter of environmental degradation. We're at a moment now that we were perhaps at for something like quote unquote climate anxiety 5 or 6 years ago. We're just beginning to hear whispers of this kind of unified field of research unfolding now. By way of illustration, the Kavli Foundation in LA, this is a foundation that invests in basic science research, just last year launched a first of its kind, $5 million initiative related to specifically funding neurobiology research in changing ecosystems, right? This was the first time that anyone had sought to specifically target neuroscience investments related to environmental change. And what did this initiative ultimately do in terms of furthering the discussion? As of January of this year, it looks like the National Science Foundation has gotten on board and is partnering with Kavli to make additional investments in this space. And so I think we're kind of just at the cusp of a certain renaissance of research here, wherein as compared to 5 or 6 years ago when I was beginning to pull at these threads and all of the researchers were siloed off from one another, I think today these folks are beginning to talk, and scientific funders are beginning to direct investments toward the type of intersectional account that I think is going to be necessary for grappling with these effects in substantive terms. So it remains to be seen, but I suppose where I see the field going is people are beginning to pay attention to the fact that the intersectional account matters. And we're beginning to see communications efforts, scientific investments, research itself flow toward that intersection.
And finally, is there resistance within the scientific community or resistance with respect to some of the research because of the partisan nature of all of this?
I haven't encountered any scientific resistance per se in terms of, oh, hey, I don't want to touch this thing because I'm a neuroscientist and it's got climate politics on top of it. But it is true that many scientists with whom I've spoken over the years are hesitant or can be hesitant to engage in policy, right? To engage in policy advocacy or political advocacy. So almost by definition, to the extent that climate change is a partisan field in the United States, you can imagine that a scientist who doesn't want to be perceived as partisan may shy away from working on something that is explicitly suggesting a climate angle in their work, especially if their work might not necessarily otherwise traditionally intersect with a climate angle. All that said, I haven't really observed folks shying away from the research in question, though I will offer in the case of these investments that I named on behalf of the Kavli Foundation and NSF, they're not actually framed in terms of climate change per se. And your question strikes me as somewhat, how do I say this? I think there's perhaps an intuitive reading that is coming to mind now as to why that's true, right? All of these investments are being made in terms of changing ecosystems writ large, right? Environmental change writ large. It's certainly true that the funders in question acknowledge the reality of climate change, but the research agenda is actually broader than climate change per se. And that, I kind of just made a remark about the fact that maybe that's a political decision. Hey, let's kind of get the climate stuff in under the radar. Maybe there's a little bit of truth to that. But in reality, I think the reason that framing exists is because the interactions in question, right? The environment brain interactions in question, they do transcend climate change. Climate change is that which in the present moment gives us reason to pay extreme attention to these effects. But it is as a phenomenon not any different from any other form of environmental change. And so, investment in this field, thinking about future directions in this field, I imagine that they're necessarily concerned with environmental vectors other than climate change, simply because researchers who are interested in the brain know that climate change isn't the only environmental vector acting on that organ.
Clayton Page Aldern, his newest book is The Weight of Nature, How a Changing Climate Changes Our Brains. Clayton, I thank you so much for spending time with us today here on the Who, What, Why podcast.
Thanks so much for having me, Jeff.
Thank you. And thank you for listening and joining us here on the Who, What, Why podcast. I hope you join us next week for another radio Who, What, Why podcast. I'm Jeff Sheckman. If you like this podcast, please feel free to share and help others find it by rating and reviewing it on iTunes. You can also support this podcast and all the work we do by going to whowhatwhy.org/donate.